we will have to define a system first and what is happening and all of those things. Then only we can talk about state variable. So any property can be state variable depending on what we are trying to observe. So temperature can also be a state variable. You can also have pressure as a state variable. You can have what else as a state variable? You can have volume as a state variable. You can have energy of that particular system as a state variable. Further, you will see enthalpy of that system, entropy of a system, free energy of the system. Similarly, for example, path function can be the work done. Another state variable can be like how much work is there in the system. All of these things are what? All of these things are state variable. All of these things are state variables. Now, what is state function? So state function and state variable, these are different. So whenever we talk about state variable, we have to define the system first of all. But state functions are functions which are depending only on the state. For example, if I am cooling something, for example, from 100 degrees Celsius to 25 degrees Celsius, if I'm cooling something, then it doesn't matter whether I am cooling in a refrigerator. It doesn't matter whether we are cooling in a refrigerator or we are cooling like not in a refrigerator, just I'm keeping the food items or whatever I'm trying to cool the system away from heat, right? So we can cool in both the cases. But what is going to matter? The process is not going to matter. Only what's going to matter is the temperature initially and finally. So these are what? These are the state function. These are the state function. Now you will see path functions such as work. So work depends on what? Work depends on the path, right? So for example, path function means how the work is done. How the work is done. So if you are lifting something, then the work will be different. If you are moving something, then the work will be different, right? So it depends on what? It depends on the path of the process. It depends on the path of the process, fine? So all of you understood the difference between state variable and state function. State variable क्या है? State variable कुछ भी property हो सकता है, कोई भी property, work हो गया, heat हो गया, कुछ भी property, whatever property, it can be state variable. It can be. But state functions are some functions which are only dependent on the state and not the path of the process. Is this clear? Yes or no? Please tell me.
Yes, sir. Yes, sir.
Yeah. Right. Achha. Next is please see. We talked about different types of thermodynamic process. So we said that isothermal process is there. So the name itself says isothermals. Then what is going to happen? In this, the temperature is remaining constant. Temperature is constant. So if temperature is constant, then we can write the delta T will be equal to 0, right? Change in temperature is equal to 0. Similarly, adiabatic, if I am writing adiabatic process, then it is going to be no exchange of heat, So I can write the heat involved, heat is given by Q, it will be equal to 0. Heat exchange in the system, it is equal to what? 0. Similarly, you will have isobaric process. Isobaric process is going to be pressure is constant. So the delta P will be equal to 0. There is no change in pressure. Isochoric process. Isochoric process. In this case, what is going to happen? The volume remains same. Volume is constant. Now, when volume is constant, then we can write delta V, it is equal to 0. Delta V, it is equal to 0. And in cyclic process, after various process, system returns to the initial state. That means change kuch khas aata nahi hai in cyclic. After that, we have two different types of process, which is very important to understand. That is why I will make you understand this using an analogy. Okay, we are going to use analogy. Please try to concentrate. Don't write anything. Leave your pen aside. Relax and just listen what is happening. Okay, just listen what is happening. Now, for this, I need a photo. वो photos जरा हम ले लेते हैं. Sure. Let us see. Let us suppose what is happening. I have some container like this. Okay, I have some container like this. Please don't write anything. Please don't write anything. Listen very properly. Okay. and in this we have a piston. So piston को थोड़ा सा bold कर देते हैं. सही है, ये piston हो गया. And then we can piston holder होगा एक. piston holder को ये मोटा कर देते हैं ना. सही है, सही है. No need to make the shape and all, okay? इसको हमने थोड़ा ऊपर कर लिया, ठीक है, चलिए. Okay, now please see. And let us suppose we have a bag of sand. Okay, we have a bag of sand, or you can see some grain is there. Okay, some grain or some sand is here. Now, please, what is going to happen? Okay, ध्यान सुनिएगा, all of you guys, please try to listen very properly. Just let me know. Am I audible clearly? Yes or no? Please tell me.
Yes, sir. Yes, sir.
Please see, guys. Now I want to get all of these sand, whatever I'm having, or grain, you can say. Na? You can also have rice grains here. So whatever rice grain or sand we are having here, I just want to fill it on top of this particular piston. So if I am going to dump all of these sand or wheat or grains in this particular, what I will say, in this particular piston, then what is going to happen? Obviously, it is going to go down. Yes or no? सही है?
Yes, sir.
सही है ना? आया ना बताएं?
Yes,
If I will dump it down, then what is going to happen? These sand particles will be pushing the piston down, and you will be having sand particles here. अरे हाँ है ना, कुछ तो बोले. सही है?
Yes, sir.
What I am doing?
Yes, sir.
है ना? I took the sand bag and I dumped it. Okay. ठीक है, I dumped it. So this is the change that we are going to talk about. बहुत ध्यान समझिएगा इस चीज को, ठीक है? बहुत इंपॉर्टेंट है, प्लीज ध्यान समझिएगा. Now see. Please try to answer me, okay? There are two ways of dumping all the sand on this piston. I want to dump all the sand where in the piston. There are two ways of doing it. Either what I will do, I will pour the sand all at once. What I can do? There are two ways, na? I can pour or dump sand. Please don't write anything. Sand all at once. Or another way, which is going to take a lot of time, but still we can talk about, in the sense that we can, like, ideally speaking, something can happen like this. Na? I will take 1 grain of salt, 1 grain of sand, right? 1 particle of sand, then I will put it here. Then I will take another, then I will put it here. And slowly, what will happen? I will be putting more and more particles of the sand, and then I can dump the complete thing. Hai? That can also happen. Sahi hai? Sahi hai?
Yes, sir.
So what I can do? I can dump 1 particle of sand dump one particle of sand at a time. ठीक है, at a time. अच्छा, अब थोड़ा ध्यान से सुनिएगा, ठीक है ना. सो व्हाट इज माय इनिशियल, ध्यान से, बिल्कुल ध्यान से सुनिएगा, ठीक है ना. बहुत इंपॉर्टेंट सवाल है, ध्यान सुनिएगा. बिल्कुल कुछ लिखना नहीं है आप लोगों को, ज्यादा दिमाग नहीं लगाना है, ठीक है ना. माय इनिशियल फेज इज दिस वन वेयर आई डोंट हैव एनी सैंड पार्टिकल्स. सही है. व्हाट इज माय इनिशियल फेज, प्लीज टेल मी गाइस, व्हाट इज माय इनिशियल फेज. What is my initial phase? Tell me.
Where you have not dumped any sand.
So sand particles are not dumped. And what is the final?
Where you have dumped the sand.
Where we have dumped the sand. है ना? अच्छा. Just a second. ध्यान सुनिए. ध्यान सुनिए. Now, initial is where we have no sand at all on the piston. Final is something where we have all the sand particles, okay. Now if I talk about this particular dump sand all at once, then as soon as I dump it, I will reach the final state. Correct hai guys? Yes or no, please tell me.
Yes, sir.
Yes,
Can
sir.
I stop it in between? बोले, can I stop it in between? Logically बोलिएगा. नहीं ना, ठीक है. सुपर पावर ऐसे सोच के मत है ना. पावर पफ गर्ल्स और कोई आयरन मैन सुपरमैन बन के नहीं सोचेगा. नॉर्मल इंसान की तरह सोचिए. If I am going to dump it all at once, can I stop it in between? नहीं ना, बोले. No, we cannot, right? But when we choose the second way, then in that case, what is going to happen? There will be small steps involved, right? One grain of sand, the piston will be lowered a bit. Another grain of sand, the piston will be lowered another, thoda sa. Then you will have another particle. So, but I can reverse this at any point. Correct, guys? Yes or no? Please tell me. हम उल्टा जा सकते हैं ना?
Yes.
बात समझ में आ रही सबको? हाँ या ना? अब्दुल हमीद,
Yes,
आलिया,
sir.
ऑल ऑफ यू. यस, ठीक है. तो यही है दूसरी चीज, तो क्या बोलते हैं, जो डंप सैंड ऑल एट वंस हो रहा है ना, इट इज इररिवर्सिबल प्रोसेस. कैसा हो गया ये? दिस इज इररिवर्सिबल process, and this will be reversible process. और समझ में आ गई सबको? हाँ या ना बताएं. ठीक है.
Yes, sir.
रिवर्सिबल एंड इररिवर्सिबल. अच्छा, अब इसी में धीरे धीरे ना, अब हम बिल्कुल आसानी से आप लोगों को इसमें what I can do, I can give you the difference between reversible and irreversible very easy by the example of, I will be writing one point, explaining it in terms of what? The sand particles. In terms of what? In terms of the sand particles. ठीक है ना. ध्यान से जरा देखते हैं. कुछ लिखने की अभी जरूरत नहीं है आप लोगों को, बस सुनिए, समझने की कोशिश कीजिए, एंड समझने के साथ साथ ट्राई कीजिए कहीं डाउट तो नहीं है आपको, है ना. इफ यू आर हैविंग एनी डाउट, प्लीज करेक्ट द डाउट अभी ही, है ना. बात के लिए कुछ ना छोड़ें कम से कम इस चैप्टर के लिए, ठीक है. If I define irreversible process, then I will define it as the process whose direction when I say direction, that means the direction of change, है ना. So direction of change cannot be changed at any stage. Say in reversible what can happen? Process whose direction can be changed at any stage. समझ में आ रही है? ठीक है. So next point here it is, process whose direction can be changed at any stage. Can be changed at any stage. ठीक है. At any stage. अब ध्यान सुनिएगा जरा, ध्यान सुनिए, ठीक है. ध्यान से वापस से इस पॉइंट पे आते हैं. I explained one thing, एक पॉइंट लिखा हमने, ध्यान सुनिए. बिल्कुल ध्यान से, कुछ नहीं लिखना आप लोगों को, जैसे आप लोगों ने ध्यान से सुना वैसे ही। अच्छा, I said my initial stage is no grain of sand in the piston. My final stage is what? My final stage is grains of sand in the piston. Grain of sand in the piston. But if I try to think in the consequence, what is the consequence of it? So I can say that initially piston was above. Finally piston पहले ऊपर था, piston अब क्या हो गया है? Piston is now, बोले हैं कंप्लीट तो करते हैं। हाँ जी,
Down. Down.
डाउन। पिस्टन था पहले अप, पिस्टन हो गया है डाउन। पिस्टन था पहले अप, पिस्टन हो गया डाउन। अच्छा, ये बताइए, डाउन, हु इज गेटिंग द पिस्टन डाउन? व्हाट इज गेटिंग द पिस्टन डाउन? द ग्रेन्स ऑफ सैंड। माइक ऑन करके रखे तो ज्यादा बेहतर होगा, बहुत कुछ लोग, कम से कम मरियम, आलिया, दोस्त स्पीक, सारा, अब्दुल हमीद, है ना, ऑल ऑफ यू गाइस। बहुत लॉजिकल सवाल है, कुछ ऐसा केमिस्ट्री भी नहीं है यहाँ पे ना, सोच रहे हो हम अभी सिर्फ बात चीजों के बारे में, वी आर जस्ट थिंकिंग अबाउट थिंग्स, ठीक है ना। सो प्लीज ट्राई टू आंसर ऑल ऑफ यू गाइस। बताएं, what is getting the piston down?
The sand.
The sand particles, the grains of sand. So the grains of sand, they're applying some kind of pressure, then only the piston is going down. See, then only the piston is going down. But how is the piston up? So piston is up because there will be some gas particles here present before, and these gas particles are applying some kind of pressure on the piston like this. When a grain of sand comes, it applies a pressure like this. So this red part is the driving force of the change. If the red part is not there, the red force is not there, the piston will not go down. So I will say the change, whatever the change is happening, it is because of that red force. Is that clear? Yes or no? Please tell me.
Yes, sir.
And
Yes,
the
sir.
force which drives the change, the force जिसकी वजह से change होता है, ठीक है ना? So the force which drives the change is known as driving force. Now, if I talk about the irreversible manner, then आप ये बताइए, the driving force, the red force will be very large than the white force, correct है? Then only ना instantly the piston is going down. इससे अब हम दूसरी चीज क्या लिख सकते हैं, ध्यान दीजिएगा जरा। When I'm talking about the irreversible change, when I'm pouring all the sand down at once, then what is happening? Then in that case, I will write the driving force is different than opposing force, is different than opposing force, ठीक है? Now let us come back. So we have dumped sand all at once. Now let us dump only one sand particles. What do you think about the red force and the white force? Will you see any considerable, any significant change in the position of the piston if I add just one grain of salt? Logically, 7th class के बच्चे जरा बताइए, नहीं ना? So what I will say, driving force मतलब ऐसे धीरे धीरे सैंड पार्टिकल डालते जाइएगा, थोड़ा सा तो बड़ा होगा, थोड़ा सा बड़ा, लेकिन बहुत मतलब इन्फिनाइटली स्मॉल डिफरेंस होगा उसमें, सही है ना? आई एम नॉट सेइंग इन्फिनाइटली लार्ज डिफरेंस, आई एम सेइंग इन्फिनाइटली स्मॉल डिफरेंस होगा। और उसी इन्फिनाइटली स्मॉल डिफरेंस या फिर इन्फिनाइटली स्मॉल जो वर्ड है उसको बोला जाता है इन्फिनिटेसिमली। अब उसको हम लिख देते हैं, तब आपको समझ में आएगा। ध्यान से देखिए, देखिए ध्यान से बिल्कुल। See here, the driving force, I will write the D dot F dot, you will understand from the previous point, the driving force is only infinitesimally greater than the opposing force. And all of you understood the second point, yes or no? Please tell me.
Yes, sir.
Yes.
ठीक है, अब हम जो अगला पॉइंट में जा रहे हैं, you don't need any explanation for this, ठीक है? See here, it is done rapidly. Here we can say that it is carried out again, it is carried out in infinitesimally small steps. तो इसको क्या लिख सकते हैं? It is carried out in infinitesimally small steps. और इन्फिनिटेसिमली स्लोली कर लेते हैं, इसमें रैपिडली का अपोजिट स्लोली होगा, तो स्लोली लिख दिया हमने, ठीक है ना। चलिए नेक्स्ट पॉइंट प्लीज राइट। इफ यू लुक एट दिस पर्टिकुलर पॉइंट, देन यहाँ पे आपको समझ में आ रहा होगा, व्हेन आई एम एडिंग ओनली 1 grain of salt, then opposing force and driving force are almost equal, so we will say that at each stage equilibrium is maintained, है ना। I mean if you add 1 grain of salt, added 1 particle of the salt बोल रहे हैं, sand, you added 1 particle of the sand, then you added another particle. If you move from 1 particle to the second particle, you will still not see any significant change. Similarly, if you go from 2 to 3, you will not see any significant change. 3 to 4, you will not see any significant change. So that is why what we will say for the reversible part is that equilibrium is maintained at all stages. We will say equilibrium is maintained at all stages. Here I can say equilibrium is not maintained. Obviously, if the driving force and opposing force are vastly different, then how the equilibrium will be maintained? Equilibrium is not maintained. बात समझ में आ रही सबको, हाँ या ना अभी तक? हाँ जी,
Yes, sir.
ठीक है। अब लास्ट समझिए जरा, अगर हम बात करें
Until
हाँ,
the
tell me.
end, the equilibrium will be the same in reversible.
Sorry?
So until the end, the equilibrium will be same in reversible.
No. We are talking about different stages, okay? Talking about different stages. So I add 1 grain of salt. So before adding a grain of salt, after adding a grain of salt, the equilibrium is
Okay.
maintained. Then I added another grain of salt. Then also, there will be no significant difference, right? So if you view one particular stage at a time, there will be no significant difference. Even at the end, you will not have any significant difference. जो difference होगा ना, इतना छोटा होगा, and because again you will see that it is imaginary. The reversible process, it is ideal process, जो imaginary process होता है ना? Natural process that we have generally, these are irreversible. ठीक है? So even at the end, the equilibrium will be maintained. Okay, Harsha?
Okay, sir.
चलिए, see the next one. The last point is all natural process. So यहाँ पे हमने space क्यों छोड़ दिया? Just a second. All natural process are irreversible. Irreversible process. So we will write reversible. These are, it is imaginary process. अब थोड़ा ध्यान से समझिएगा इस बात को, आप लोग प्लीज ये मत समझिएगा कि if a see reversible and irreversible, if you see the definition, it is not, हम ये नहीं कह रहे हैं कि we cannot pour back this, I mean whatever sand we have poured here in the piston, we can't pour it back to this, we can't pour it back to the sac, right? We can pour it back to the sac, but that is another process, that is another change happening. So if you look at the definition of the definition of a reversible or irreversible process, so it is talking about only one single change. While the change is happening, you cannot change the direction. While the process is happening, you cannot stop the process and reverse it. Once the process has ended, obviously you can reverse it back. Now I can take the sand particles from the piston, I can put it back on the sac. So you will say, oh my God, sir, ये तो reversible हो गया. How it is imaginary? I can do imaginary. वो बात नहीं है, ठीक है ना? बात ये है, once the process is happening, at that point you cannot reverse it. That is irreversible process. ना तो process irreversible है, बात समझ में आ रही है सबको, है ना? तो change की बात है ना, change नहीं है कि change ऐसा नहीं वापस नहीं आ सकता. Process is irreversible. Is this clear? Yes or no? Please tell me. ये सारे doubts आते हैं है कंसेप्चुअल चैप्टर, इसलिए लोगों आपने पढ़ा था, है ना, हमने क्या पढ़ाया था, आपने पढ़ा, है ना, आपको समझ में आ रहा होगा लोगों ने ऐसा क्यों किया है। बात सही है, हाँ या ना? इस
Yes,
चैप्टर को
sir.
पढ़ने के बाद
Yes,
लोगों
sir.
ने अपने साथ क्यों क्या किया वो समझ में आ, ठीक है। चलिए नाउ ये बात आप लोगों को सब कुछ समझ में आ गई, इरिवर्सिबल एंड रिवर्सिबल, इवन दो हमको लगता है बहुत, ऑल ऑफ यू डन राइटिंग दिस, यस और नो, प्लीज टेल मी, एनीवन स्टिल राइटिंग?
No, sir.
No, sir.
है ना, हमको पता था, हमने बोला था कुछ नहीं लिखना, लेकिन बच्चे मानेगा, है ना, हमने बोला था इफ एनीवन इज राइटिंग प्लीज लेट मी नो, तो हम थोड़ा रुक जाएंगे, अदरवाइज अगर सबने लिख लिया है लिखने की तो ओ माय गॉड, छाप ले किताब आप लोग एनसीईआरटी लेके, है ना, लिखने की क्या है इतनी आप लोग जल्दी मची रहती है, हम बताएंगे जब आप लोग लिखा कीजिए, ठीक है ना, जब नहीं बोले सुनिए, अभी तो सुनने की कोशिश किया कीजिए, ठीक है। लेकिन अब्दुल्ला, ओ दिस इज अब्दुल्ला अल फराज, अच्छा फराजी है, ठीक है, यासिर इज हियर, अब्दुल हमीद, अब्दुल हमीद आपको समझ में आ रहा है, हाँ या ना बताएं,
Yes, sir.
है ना, कोशिश करते रहिए थोड़ा, ठीक है ना, समझ में आता रहेगा।
Yes, sir.
लेट मी गेट माय ईयरफोन, आपकी आवाज बहुत धीमी आ रही है। ओके, नाउ लेट अस मूव ऑन टू द अनदर टॉपिक, ध्यान सुनिए जरा। Obviously when we are talking about thermodynamics, तो अब तक आपकी कहानी आगे बढ़ के एनर्जी तक आ जानी चाहिए। So first of all we will talk about internal energy, ठीक है ना, we'll talk about internal energy. Internal energy, please see. So what is internal energy? First of all, internal energy will be defined for a system, right? In thermodynamics, we will first of all do what? We will first of all define a system. What is our system? Whatever energy is present in that system, that is its internal energy. You know, simple definition of internal energy is what? Sum of all forms of energy stored in all forms of energy stored in a system. All forms of energy stored in a system. Achha. Now, please understand that. Please understand. If you remember something from the 9th standard, you know, try to remember something from the 9th standard. If a body is moving, it would have what kind of energy? If a body is moving, it would have what kind of energy? What is the name of
Kinetic
it?
energy.
Kinetic energy. Very good. Kinetic energy. If a body is at a certain height, then what type of energy it will have? It would have
Potential.
Potential.
Potential energy.
very good potential energy, right? Achha. So let us suppose a body. Let us suppose we have a body, and it is moving. So while it was moving, it was having kinetic energy. While it was moving, it was having kinetic energy. But once it stops moving, it does not have kinetic energy. Correct? Hai? Yes or no? Please tell me.
Yes,
Sahi hai,
sir.
Aya?
Yes, sir.
But it can have some other energy, right? Yes or no? Please tell me. अगर हम बात करें, फॉर एग्जाम्पल एक बात करते हैं, थोड़ा समझने की कोशिश, बट तो समझने की कोशिश कीजिए। लेट्स सपोज वी हैव सम हाइट हियर, h हाइट, एंड हवा में इस तरह से, वो ये देखा है ना आपने, हैरी पॉटर देखा है आप लोगों ने? गाइस हैव सीन हैरी पॉटर?
Yes, sir.
At least you would know about Harry Potter, right? They have some broomsticks ना which can fly and all. वो फुटबॉल मैच हो रहा है, ठीक है ना, तो फुटबॉल मैच जैसे हवा में हो रहा है, फुटबॉल पता नहीं क्या बोलते हैं हमको, फुटबॉल याद आ रहा है, फुटबॉल है, ठीक है। तो what is happening, that ball is moving from this direction and it stops in air somewhere here, no? Because somebody stops it, ठीक है। So but it is still in the air, right? It is still in the air. So right now it is having potential energy as well as kinetic energy, right? When it moves and it is stopped by another player here, then it is only having how, what? It is only having the potential energy. Correct, guys? Please tell me.
Yes,
Correct?
sir.
Yes, sir.
Now, where did the kinetic energy go? So you can answer it in different ways. You can see that as that particular ball, it hits another player's stick or whatever they are using, I don't know. It hits their stick, then there will be some sound. So kinetic energy is converted to sound energy. Then some force will be absorbed by that particular person, right? So it's his bat or whatever they are holding stick. It will move backward, right? And they will store it once again. Some of the kinetic energy will be gone because of the because of the air resistance. So all of these things will be, the kinetic energy will be converted to all of these particular things. You know, sound energy, due to air resistance, there will be not there. Achha. But the potential energy is still here. Correct, guys? Yes or no, please tell me.
Yes,
Yes,
Is
sir.
this clear?
Yes, sir.
Okay. So that is the meaning of internal energy. So right now, initially, the body had potential as well as kinetic energy. Body had potential as well as kinetic energy. Now this particular ball, it has only potential energy. अब ये तो बात होगी आपकी जब हम लोग बात कर रहे हैं किसकी? When we are talking about object which in macroscopic level, but please understand, if you go to the molecular level, all of you go to the molecular level. When you go to the molecular level, you will see atoms, and atoms will be vibrating. Correct, guys? Yes or no? Please tell me.
Yes,
They will
sir.
be vibrating. So atoms are, even if you have solid state, these atoms are vibrating. So there will be vibrational energy, right? They will be vibrating, and because they're attracted by another atom. If you're taking a metal, so if there is attraction anywhere, there is a potential energy. Why do we have potential energy? It's because of gravity, right? So wherever you have attraction, there will be potential energy. The body can move linearly in a line, so it will have translational energy that we call as kinetic energy, right? If something is rotating, it will have what? It will have rotational energy, right? So there can be many different types of energy in a body. So internal energy is generally represented by U, and U, it is equal to potential energy. अच्छा ऐसे लिख देते हैं, आप लोगों को थोड़ा ज्यादा अच्छा है, ऐसे लिख दें क्या? चलिए ठीक है, ऐसे लिखते हैं, पोटेंशियल एनर्जी प्लस काइनेटिक एनर्जी, राइट? तो ये तो आप लोगों को पता ही है। नेक्स्ट यू कैन हैव वाइब्रेशनल एनर्जी, then you can have translational energy, you can have translational, trans करके तो वाइब्रेशन तक तो पता चल जाएगा आप लोग को, translational energy. Then you can have what? You can have rotational energy. And other different types of energy, right? But whenever a process will happen, whenever, for example, this ball moved from here to there, not all energy will be what? Not all energies are important. When the ball was at a certain height and it was moving in this direction, we can ignore the potential energy because it is not changing. Whatever change is happening is because of the kinetic energy. And also, if I talk, this particular case was a very simplistic case of the ball, right? But if I talk ideally about each and every substance, then it is impossible to measure all kind of energies. So we generally focus on that energy which is going to change, or we focus on those energies which are going to change. So rather than calculating the complete internal energy of a system, what do? We calculate the change in internal energy. Does this make sense? Yes or no? Please tell me. Mariam, Martin,
Yes,
Yasir, Sarah. Make sense?
Yes.
Moving on, please write here. It is impossible to measure. It is impossible का spelling ही भूल गया ना. Impossible ऐसे होगा ना. Impossible. मेरे डिक्शनरी में impossible नाम का कोई शब्द नहीं है, इसलिए हम स्पेलिंग भूल गए. It is impossible to measure all forms of energy. Hence, it is impossible to hence it is impossible to measure absolute internal energy. Absolute internal energy. Okay, please write next. Rather the change in internal energy, the change in internal energy can be measured. In the internal energy can be measured. Okay. Please write. So what we will say, delta U change is represented by delta. U will be equal to the internal energy final minus internal energy initial. ठीक है ना? अब एक चीज का ध्यान रखिएगा. This is the formula for what? Tell me guys. This is the formula for
Change in internal energy.
नहीं, फॉर्मूला नहीं है change in internal energy का. थोड़ा अभी तो सोचिए ना आप, अगर हम if we could have measured the internal energy in final state and initial state, तो ये तो हम लिखते ही ना, it is we have written it is impossible. So ये फॉर्मूला कैसे हो सकता है? We cannot measure the internal energy in the final stage, neither we can measure the internal energy in the initial state. So sometimes you will see these equations and everything. So it may seem like formula, but these are generally definitions. What is change in internal energy? So it is the difference in the internal energy, the final and the initial state. That is a definition. It is not a formula. We are never going. This is not a formula. बात समझ में आ रही सबको? All of you get the difference here. Yes or no? Please tell me.
Yes, sir.
है ना? तो ये भले ही देखिए आंखों का धोखा, फिर बोलते हैं बच्चे सर फॉर्मूला कौन सा लगाए? तो फॉर्मूला ये है ही नहीं. ठीक है? इट इज द जस्ट द डेफिनेशन कि चेंज होता क्या? तो चेंज इज फाइनल माइनस इनिशियल. हमने बताया कि फाइनल माइनस इनिशियल. ध्यान रहेगा सबको? ऑल ऑफ यू सुनो प्लीज टेल मी. याद रहेगा
Yes,
ना?
sir.
ठीक है, चलिए. कोई बोले अगर ना कि फॉर्मूला है तो बोलिए ना, फॉर्मूला हो ही नहीं सकता. जब हमने पहली मतलब चेंज की बात तो तभी आई ना, व्हेन वी सेड दैट इट इज इम्पॉसिबल टू मेजर एब्सोल्यूट इंटरनल एनर्जी. इट इज इम्पॉसिबल. तो अब इम्पॉसिबल बोल के फिर हम लोग फाइनल माइनस इनिशियल क्यों करें? है ना, बेवकूफी वाली बात हो जाएगी. ठीक है, ऐसा नहीं. देखिए हम बिल्कुल एक एक चीज पढ़ा रहे हैं आप लोग, ठीक है, ताकि आप लोग समझिए. समझ के कम से कम ऐसा ना हो जैसे दूसरे लोगों के साथ हुआ है. नहीं समझेंगे तो फिर बहुत गड़बड़ होगी. ठीक है, चल ओके. और दूसरी बात ये भी है कि जिन लोगों ने मतलब ऐसे कोई सब्जेक्ट पढ़ रहे हैं जिनके लिए लोगों ने जान दे दी, है ना, मतलब जान ली दे भी नहीं दी, अपनी जान ले ली खुद की, तो उनकी जान भी ऐसे वेस्ट में ना जाए, है ना. इट शुड नॉट गो इन वेस्ट, राइट. दैट इज व्हाई वी हैव टू अंडरस्टैंड एवरीथिंग. हर एक चीज बिल्कुल बोलो समझा के गए इसी वजह से. तो चलिए, अच्छा अब हम लोग थोड़ी बात करते हैं कि एनर्जी चेंज होगी कैसे. ठीक है, व्हाट इज द सी एनर्जी. तो एनर्जी कैन नॉट बी डिस्ट्रॉयड, नाइदर इट कैन बी क्रिएटेड. सो एनर्जी कैन आइदर बी ट्रांसफॉर्म्ड और इट कैन बी ट्रांसफर्ड. It can be transformed from potential to kinetic, kinetic to potential, mechanical to electrical, electrical to light, right? Or it can be transferred from one body to another. That's it. We have already said in this chapter we will be dealing only with transfer of the energy. We are not going to deal with the transformation of energy. We are only going to deal with transfer from one body to another. Transfer of energy from one body to another. Now, ध्यान से समझिएगा जरा. दो चीजों को हम बता रहे हैं, ठीक है ना, दो चीजों को हम बता रहे हैं. देखिए, कुछ लिखने की जरूरत नहीं है, कुछ लिखने की जरूरत नहीं है. हमको करना है एनर्जी चेंज. हमको क्या करना है? आई हैव टू चेंज द एनर्जी ऑफ अ सिस्टम. आई हैव टू चेंज द एनर्जी ऑफ अ सिस्टम. पुराना हमारे पास था इतना बढ़िया सा, उसी को लेना था. बेकार हमने नया बनाया. चलिए कोई बात नहीं, बना दिया तो बना दिया. बनाने की बिल्कुल किसी को जरूरत नहीं है, है ना. हम बना रहे. ओह माय गॉड, आई एम मेकिंग दिस सो नोबडी हैज टू मेक, ठीक है ना, बिल्कुल आराम से रहिए आप लोग, ठीक है, आराम से रहिए. Let us suppose we have a piston like this, we have a piston like this, ठीक है, and here inside we have some gas particles, we have some gas particles. Oh, too much big, but थोड़ा अच्छा ही लग रहा था. एक काम करते, सारे इसको यूज नहीं करते हैं, है ना. अब तो how to change this, other time modify tool, add pen, थोड़ा छोटा कर देते हैं बस, ठीक है. चलो. Here we have gas particles. So, and the piston is in this position at rest, है ना? I mean, piston is not either, neither it is going down nor it is going up. So it is in equilibrium right now. It is in equilibrium right now. Now, obviously speaking, if I lift this piston up, क्या करते हैं हम इस piston के साथ? है ना? If this piston is lifted up, ठीक है ना? I'm making two things. ये आपका initial stage है, and this is your final stage, ठीक है? I have to lift the piston up. I have to do what? I have to lift the piston. Not lift the piston up, मतलब हमको final stage क्या चाहिए? The piston is above. The piston ऊपर है. अरे बात समझ में आ रही है सबको? है ना? ना हम करेंगे ना आप कीजिएगा, बस हम एक बात बोल रहे हैं. I need a final stage in which the piston is up. ऊपर है piston. बात समझ में आ रही है सबको? है ना? जल्दी बताएं.
Yes, sir.
Okay, कैसे होगा क्या होगा वो देखेंगे बाद में, लेकिन हमको piston चाहिए ऊपर. So obviously if I am changing like this, तो ये जो हमारे पास सिस्टम है यहाँ पे, the gas particles that we have, their energy will obviously, there will be some change in their energy. बात सही है ना? बताएं. There will be some change in their energy ना, when if their constant is changing, उनका volume change हो जा रहा है ना, they have a larger volume, right? So obviously what is going to happen? Their energy is also going to change. There will be some change in their energy as the piston is lifted up. बात समझ में आई सबको? है ना? बताएं. अच्छा वो आप छोड़िए, अगर आपको ये लग रहा है सर कैसे होगा सर, तो सुनिए. If I heat this, if I give heat to the system, if I give heat to the system, then what will happen? These gas particles will be moving around rapidly now. They will be moving around rapidly, and what will happen? They will slowly lift the piston up. सही है हाँ या ना बताएं? They will start to
Yes.
lift the piston up. अच्छा, अब आपको बिल्कुल समझ में आ रहा होगा. हाँ सर, एनर्जी चेंज तो होगा क्योंकि हीट कर रहे हैं. बात समझ में आई सबको? हाँ या ना? All of you got this? Yes or no? Please tell me.
Yes.
I am heating. ठीक है. अरे भाई अब सुनो, क्या सेम चेंज ऐसा नहीं कर सकते कि मतलब उठाना ही तो है, तो आप हीट देके क्या करो? वॉट एवर हीट यू आर गिविंग टू द सिस्टम, it is used for lifting the piston up. It is used for do what? It is used for lifting the piston up. हम इसको हाथ से भी उठा सकते हैं, है ना? बात समझ में आ रही नहीं आ रही बताइए?
Yes.
असली समझ रहे?
Yes, sir.
ठीक है, अब सुनिए जरा ध्यान से. So there are two modes of changing the energies. There are two modes. Either it can involve heat or it can involve work. So these are the modes of transfer. These are not energy. Energy नहीं है. Heat क्या है? What is heat? It is not a form of energy. किताबों में लिखा रहता है. मतलब क्या ही बोले? किताबों में लिखा रहता है heat is not a form of energy. Heat is a mode of transfer of energy. Thermal energy is the energy due to temperature. That is for sure, there is energy if you have a higher temperature substance, but it is not heat energy, it is thermal energy. What is heat? Heat क्या है? Heat आप जब तक किसी चीज को छूओगे नहीं, heat के बारे में कुछ पता कैसे लगेगा? Heat तो महसूस होती है ना चीज. So it is a mode of transfer of energy. Similarly, work is also what? There are only two modes of transfer of energy. There are only two modes of transfer of energy. It is one is heat and the other one is work. आपको बिल्कुल समझ में आ रहा होगा heat और work में कितना अभी relation समझ में आ रहा नहीं आ रहा बताइए. What is heat doing? Lifting the piston up. What is what is someone who is lifting the piston up doing? He is doing work against gravity. So that will be what? That will be again, that will be work. Both are doing the same thing. अरे भाई आप ये समझो जरा, आप ये समझो जरा कि अगर आपने आके देखा सिस्टम में क्या है, पिस्टन ऊपर है, यू विल नेवर नो ना, यू विल नेवर नो कि चेंज हुआ कैसे. दो चेंज हो सकता है, आइदर हीट्स के थ्रू हुआ हो और इट वुड हैव बीन बाय द वर्क. अगर कोई ये बोले, प्लीज रिमेंबर, इफ समबडी इज गोइंग टू से, बहुत सारे लोगों के मन में ये चीज आ रही होगी, सर व्हेन आई विल हीट द सिस्टम देन द टेम्परेचर विल चेंज. सो वो गर्म हो जाए तो हम पता कर लेंगे कि हीट हुआ है. बट प्लीज रिमेंबर, आई एम टॉकिंग थ्योरेटिकली. आप जो बात बोल रहे हैं सही है, हाँ आप छुइएगा तो गर्म रहेगा, वो है ना, गर्म रहेगा. बट हम बोलना ये चाह रहे हैं कि whatever heat you are giving ना, whatever heat you are giving, it is not used to increase the temperature, it is used to lift the piston up. थोड़ी सी आप इसको रिलेट कीजिए, relate this with the latent heat of vaporization. When something is boiling, you are giving constant heat. When something is boiling, you are giving them constant heat, but still the temperature rises or it does not rise. बताइए, if something is boiling, will the temperature rise? मान लीजिए पानी, you have water.
Yes, sir.
नहीं, ये तो फिर आप बोल रहे. Water, what is the maximum temperature water can have? Tell me guys, what is the maximum temperature water can have?
100 degrees
100
Celsius.
degrees Celsius.
What if I give it more heat? I can still heat it now after 100 degrees Celsius, right? So what will happen?
It will remain same.
Sorry, what it will?
Remain same. The temperature.
The temperature will remain same. That means even if you heat something, the temperature can remain same. ये बात सबको समझ में आया ना? पहले बताएं. All of you understood ना? Even though you are heating the boiling water, its temperature does not change. Its temperature does not change. That means all heat does not result in increase in temperature. बात समझ में आ रही सबको आया ना? All heat,
Yes,
it does not result. Similarly, I mean, come to this part. What I am trying to say is, whatever heat you are giving, it is used. Let's say, for example, it is used for the lifting of piston up. In the boiling water, what was happening? The extra heat that you are giving, it is used for the conversion of conversion of liquid water to vapor water. From liquid water to water vapors, it was used. Here, all the heat is getting used in what? In lifting the piston up. That is why temperature will not increase. Is this clear? Yes or no? What I am trying to say is that modes of transfer of energy are only two. It is heat and work done. Right? The sitting modes of transfer of
So we're
energy.
considering an ideal situation, right?
No, we are not considering any ideal thing. Okay, we are not considering this as an ideal things. Okay. First thing is that we are considering a case. Okay, we are considering a case in which heat does not. We have seen all heat does not result in increase in temperature. Why we are applying here? That's the same thing we are applying. Okay. I'm not using the word ideal, but I can use the word imaginary case. That's in Maggie.
Yes.
Harsha, okay, I will use the word imaginary, no problem, but I cannot use the word ideal. Okay. So first one is heat. First one is heat, which is represented by Q. Okay. Now please add heat to system. Add heat to system. Then what will happen? Then we say Q is equal to positive. Q is equal to positive. Okay. What is happening here? Here the heat is going from surrounding to the system. Okay. So what is happening? Heat is going, the transfer of heat is, the mode of transfer is what? From surrounding to system. So heat is added to the system. So Q is positive. What will happen? Take heat from the system or cool the system. Take heat from system. Then in this case, the Q will be negative, because in this case, what is happening? System se heat nikal rahi hai. Heat is moving from system to the surrounding. Is this clear? Yes or no, please?
Yes, sir.
बहुत आसान है ना? ध्यान सुनिए, वर्क इट इज W, ओके, वर्क इज W, सो सेम थिंग, वर्क डन, वर्क या तो सिस्टम पे आप कीजिएगा या तो वर्क सिस्टम करेगा, प्लीज सी हियर, वर्क डन ऑन सिस्टम, work done on the system will be what? W, it is equal to positive, and work done by the system, if system is doing the work, then the work done will be equal to negative. हाँ जी, कोई दिक्कत किसी को तो बताइए, any problem till here?
No, sir.
Next, अब हमने समझा कि heat and work are the only modes of transfer of energy. That means energy of a system can change only if heat is added, or work is done by the system or on the system, है ना, if there is involvement of heat or work. So this is the basis of the first law of thermodynamics. First law of thermodynamics. बहुत ही वियर्ड स्टेटमेंट है, लेकिन उससे पहले हम आपके ही मुंह से स्टेटमेंट निकलवा देंगे. What will happen to the energy of a system? What will happen to the energy of a system which is isolated? मतलब what will happen to the energy of an isolated system? है ना, what is isolated system? You cannot exchange matter or heat. कुछ नहीं आना जाना कुछ नहीं हो सकता. It is isolated. You cannot add matter. Neither you can add. If you want to do some work, you have to add some mass or something. ना, work done अगर किसी को याद है, what is work done? F into S, force into displacement, right? What is force? Mass into acceleration. So until there is involvement of some another mass, work cannot be done, है ना. तो matter तो जा ही नहीं सकता isolated में, heat भी नहीं जाएगा. So what we can say about this internal energy? What we can say about the energy of a system which is isolated system? क्या रहेगी? उसकी एनर्जी चेंज होगी? आइसोलेटेड सिस्टम की एनर्जी चेंज होगी? बताइए.
No, sir.
No, sir.
नहीं ना. हाँ ठीक है, बस वही है. ठीक है, बड़ा ही अजीब स्टेटमेंट है, वो आप ही के मुंह से हम निकलवा देते हैं जनरली बच्चों से, तो याद रहेगा. ठीक है ना. इन आइसोलेटेड सिस्टम the energy of system is constant. बदलेगी नहीं तो क्या होगा? कांस्टेंट हो गया. समझ में आई? It is constant. That is why I will say delta U is equal to Q plus W. या तो वो हीट से चेंज हो सकता है या तो वो वर्क से, दोनों से चेंज नहीं हो रहा है. अगेन दिस, हाँ, अब ये है फॉर्मूला इंटरनल एनर्जी का. ठीक है, it is either going to be changed by Q or it is going to be changed by the work done. Now this is the formula of delta U. ये याद रखिएगा. First law of thermodynamics, in many of the books you will see abbreviation FLOT, float. ठीक है. अब थोड़े से हम लोग ना सवाल की तरफ बढ़ते हैं. कुछ अच्छे सवाल आपके पास एनसीईआरटी में ही है, उन सवालों को डिस्कस करके विल मूव टुवर्ड्स अवर नेक्स्ट टॉपिक. एनसीईआरटी क्लास 11th, the first book. This is the fifth chapter ना, fourth states, sixth chapter, my bad. Fifth chapter is states of matter, जो कि डिलीट हो चुका है. हाँ, एक चीज हम बोल रहे हैं आपको ध्यान से थोड़ा अभी. यू कैन रीड द एनसीईआरटी टेक्स्ट बुक, ठीक है, बट ओनली रीड टिल वेयर वी हैव डन, है ना. इफ यू हैव नॉट डन समथिंग तो वहीं पे छोड़ दीजिएगा. ठीक है, तो मतलब सारी चीजें वॉट एवर आई एम एक्सप्लेनिंग इट इज फ्रॉम एनसीईआरटी इटसेल्फ, बट अगेन I mean it has been written in a way that we can say that it has been written for teachers, you know, someone who has already learned this subject. So there is a problem. The first problem that we have in NCERT, it's very interesting problem. तो ध्यान से थोड़ा देखते हैं, समझने की कोशिश करते हैं. express the change in internal energy, है ना? Express the change in internal energy when of a system when no heat is absorbed, यानी कि क्या हो जाएगा बताइए, heat absorb 0, तो Q is equal to 0 आया ना?
Yes, sir.
हाँ जी बताएं, ठीक है?
Yes, sir.
But work is done on the system. So work is done on the system. So W will be positive या negative?
Positive.
Where W is positive. Work is done on the system. अब बताइए यहाँ पे what type of wall? Wall मतलब boundary. What type of wall is there? इससे आप बताइएगा. देखिए जो चीज 0 रहती है ना उससे वॉल का पता चलता है. बताइए जरा. Q is equal to 0 का क्या मतलब हुआ? Which wall?
Adiabatic.
Very good. Huh? Q is equal to 0. No exchange of heat. That is why it will be adiabatic. Very good. No work is done on the system. Work नहीं हो रहा system में. W is equal to 0. But Q amount of heat is taken out from the system and given to the surrounding. So Q is equal to positive or negative?
Negative.
Negative.
Negative. Now tell me what type of wall is present? We can exchange what? We can exchange heat, but work cannot be done. We can exchange heat. देखिए अगर boundaries को classify जो हमने किया था ना, on the basis of heat, so it was adiabatic wall, and the other thing was what? Diathermic, if you remember.
Diathermic.
Right? Diathermic wall. There is a wall, na? If you did not have any wall, then it would have been what type of system? It would have been an open system. क्योंकि open system में क्या होता है? बताएं? अच्छा छोड़िए हटाइए. Open system or closed system है ना? You can have either these two systems. ठीक है. What type of system it would be? अच्छा. W amount of work is done by the system. Q amount of heat is supplied to the system. What type of system would it be? What type of system would it be? So W amount of work is done. So W it is equal to what? Positive. By the system, so negative हो जाएगा. My bad. W will be negative because it is done by the system. Q amount of heat is supplied to the system. That means what we are doing? Q amount of heat. Q it is equal to is supplied. So positive हो जाएगा ये. Right? Q amount of heat is supplied to the system. Now, this will be a closed system. This will be a what? This will be a closed system. ठीक है. अच्छा एक और चीज. Now they are also asking about the express the change in internal energy. अगर हम internal energy की बात करें यहाँ पे, so in the first case the delta U will be equal to W. हाँ या ना? सही है?
Yes, sir.
बताइए.
Yes, sir.
ठीक है. Now in this case, in the second case, the delta U it will be equal to minus Q. Correct?
Yes, sir.
Yes, sir.
Why minus Q? हाँ जी. Why minus Q? Tell me.
Because W is 0.
Yeah, heat is taken out of the system. That is why it will be minus Q. Achha. Next is we are having delta U. It is equal to Q is positive, W is negative, so Q minus W. All of you got this? Yes or no? Please tell me, guys.
Sir, how is
Yes,
the
sir.
third one a closed system?
See, in this case, we can call it both the things. Open system, you can also call it open system, and you can call it closed system. You know? But they are not talking anything about the removal of mass or addition of mass. That is why we consider it to be closed system. Okay, so they are only talking about heat and work done by the system. ठीक है? Amount of work is done.
Right?
ये देख लीजिए. हाँ, work is done. जैसे मान लीजिए, for example, यही वाला केस आप देख लीजिए. This one, this particular case. In this particular case, what is happening? Heat is supplied to the system, right? Heat is supplied to the system, and this system is doing work on the piston to lift it up. Correct?
Yes, sir.
क्लोज्ड सिस्टम भी है ये, राइट हर्षा?
Yes, sir.
ठीक है, इट इज अ क्लोज सिस्टम आल्सो. Okay, so Q minus W. अच्छा, next what do we have? We can do some small questions on a system absorb this much of energy. Okay, चलिए ठीक है, कुछ सवाल लिख लीजिए. Write a question and then we'll move on to another topic. Determine internal energy. Determine internal energy. The positive and negative sign, it just signifies that heat is given to the system or taken away. Work is done on the system or by the system. This negative sign has nothing to tell about the magnitude. मतलब वो ऐसा नहीं कि negative work हो रहा है ना? बात समझ में आ रही है? It is just negative work means that the work is done by the system. बात समझ में आ रही है सबको, है ना?
Yes.
बोले ठीक है. Ben, please see here. A part, system absorb. System absorbs 428 joules of heat and does work equivalent to 286 joule on its surrounding. कीजिए जरा. Send your answers once you're done, guys. You can send the answer on the chat. Harsha has got the answer. Others, please send. I think it is the answer. Sara, कुछ तो mistake किया आपने क्या? Sara has done the mistake or Harsha, see your answer. Harsha, see your answer. Maybe you have done a typo there.
So is my answer wrong?
No, Sara, your answer is correct. Harsha, your answer is not right. 428 and 286, no? I think you have done some calculation mistake, Harsha.
Yeah, I took 282.
So सही करिए जरा. नो आलिया नॉट राइट। कैसे कर रहे हैं आप लोग, देखिए जरा। सिस्टम absorbs 482 joule na, of heat and does work. System is doing the work. Abdul Hamid, what is your answer? Please send your answers, guys. 2 minutes. All of you guys, please. बहुत आसान सवाल है ये तो, मतलब कुछ नहीं है इसमें। आप लोग इतना टाइम भी लगा रहे हैं और आंसर भी नहीं भेज रहे हैं बाकी लोग। Alia, send your answer on my WhatsApp. Take 2 more minutes, nothing else. I need answers from everyone. ये फॉर्मूला आपके पास है ना, W is equal to what? Sorry, U is delta U, change in internal energy. Right? Delta U, it is equal to Q plus W. नहीं मरियम, wrong. Delta U, it is equal to Q plus W. है ना? You have to just give the signs, appropriate signs. System absorbs heat, then Q is positive or negative. And if it is doing the work, it will be positive or negative. You have to just look at the notes and please do it ना. ऐसे अंदाजे से ना करें please. आलिया, प्लीज सेंड योर आंसर ऑन माय व्हाट्सएप। वो आपको वहां पे बताना पड़ेगा कि आपने क्यू को पॉजिटिव लिया है, मे भी नहीं चलेगा ना। ऑल ऑफ यू गाइस सेंड द कंप्लीट आंसर्स, सेंड द आंसर्स ऑन माय व्हाट्सएप कि आपने क्यू को क्या लिया, पॉजिटिव लिया या नेगेटिव लिया, डब्ल्यू को क्या लिया, पॉजिटिव या नहीं क्या लिया। ठीक है ना, ये बताइए आपको। फाइन, ठीक है, आपने जो क्यों किया है, लाइक एब्जॉर्ब्स मीन का मतलब, एब्जॉर्ब्स का मतलब क्या होता है, व्हाट इज द मीनिंग ऑफ एब्जॉर्ब्स? आलिया, व्हाट इज द मीनिंग ऑफ एब्जॉर्ब?
It takes it.
It is getting heat or it is giving heat?
It getting heat.
If it is getting heat, it will be positive or negative. Look at the notes and tell me.
Oh, it will be positive. Okay.
अरे वो नहीं पूछ रहे आप, नोट से पढ़िए, वो लाइन पढ़िए जरा ना आलिया, ऐसे नहीं बात होती है ना, लाइन पढ़िए। अभी तो हमने बता दिया, दो ही केस है, ट्रू या फॉल्स। ट्रू नहीं तो फॉल्स आप समझ लीजिएगा। ठीक है, पढ़िए जरा, रीड द लाइन।
Add heat to the system. Q
हाँ,
to
सिस्टम में हीट जा रही है ना, बात समझ में आई सबको? गॉट इट ना आलिया, आपको समझ में आया?
yes sir.
ठीक है, ओके। व्हाट अबाउट द वर्क? वर्क सिस्टम पे हो रहा है या सिस्टम ही काम कर रहा है, बताइए।
Yeah, I'm not getting that actually.
हाँ, यहाँ से हीट को हटा दें हम,
Yes sir.
हीट को हटा दो आप। अ सिस्टम, पढ़िए, I have removed heat ना, I mean we don't want the heat part right now. We are done with heat, so read it now. A system क्या है आगे? ओहो आलिया, ऐसे कुछ लीजिए, ये हटा दिया हमने।
Yes sir.
System
Does work.
हाँ, wait. So who is doing the work?
A system. Yeah.
हाँ, समझ में आया?
Yes sir. Okay.
ठीक है, तो बहुत हार्ड नहीं है, आसान है।
Yes sir. Yes, sir.
अंग्रेजी है थोड़ी बस, और कुछ नहीं। वेरी गुड सारा, करेक्ट है। बाकी लोग का आंसर कुछ नहीं आ रहा है ना। अब्दुल हमीद, क्यों नहीं आ रहा है आंसर? यासिर, मरियम, मार्टिन, why you guys are not getting the answer? इतना तो समझा दिया। अब्दुल हमीद, tell me.
Sir, no, sir.
What no sir? नो बोल के चुप हो गए। अरे लाइन कौन सी नहीं समझ में आई वो तो बताओ कम से कम, अब्दुल हमीद। अब्दुल हमीद।
सर आप क्वेश्चन मतलब like,
सॉरी,
आप पूरा ही समझा सकते हैं एक बार वापस से?
वापस से पूरा समझा दें हम? अरे यार एक बात बताओ, you have wait, where is that? You have written this one?
हाँ सर।
हाँ,
हाँ हाँ।
लिखा है आपने ना? ठीक है।
यस सर।
अगर सिस्टम को आप हीट दे रहे हो तो हीट पॉजिटिव में लोगे या नेगेटिव में लीजिएगा आप? सिस्टम को अगर हीट मिल रही है तो
हाँ
क्या पॉजिटिव या नेगेटिव?
पॉजिटिव।
पॉजिटिव। और सिस्टम से अगर आप हीट ले रहे हो
नेगेटिव। हाँ
सिस्टम को, तो नेगेटिव। अच्छा, अगर सिस्टम वर्क कर रहा है तो सिस्टम इज डूइंग द
पॉजिटिव।
वर्क, पॉजिटिव। सिस्टम पे वर्क कोई कर रहा है, सिस्टम पे वर्क
तो
हो रहा है
नेगेटिव।
तो
हाँ नेगेटिव नेगेटिव।
फिर से सुनिए। इफ सिस्टम सिस्टम अगर वर्क कर रहा है तो क्या होगा, पॉजिटिव या नेगेटिव? अब्दुल हमीद, सिस्टम कर रहा है अगर वर्क तो
पॉजिटिव।
पढ़िए आप, 2-3 बार पढ़िए,
अरे
स्टूती
नहीं
मत करो।
नेगेटिव।
पक्का समझ में आई?
नेगेटिव। हाँ
पक्का समझ में आई ना? अगर कौन नेगेटिव वर्क कब होता है? जब सिस्टम क्या कर रहा हो, हु इज डूइंग द वर्क?
सिस्टम।
सिस्टम इज डूइंग द वर्क, तो नेगेटिव होगा। ठीक है ना? अब समझिए, चलिए अब इधर आइए। देखिए बहुत आसान सी चीज है ना गाइस, ऑल ऑफ यू प्लीज ट्राई टू अंडरस्टैंड इट। चाहे आप सिस्टम से हीट ले रहे हो, चाहे आप सिस्टम से कोई काम करवा रहे हो, तो सिस्टम की एनर्जी घटेगी। If the energy of system is decreasing, obviously it is going to be negative. All of you got this? Yes or no? Please tell me. If you're taking something from, very very logical it is, है ना, very simple also. If you're taking something from the system, तो क्या डिक्रीज ही होगा ना? हाँ बताएं, मरियम, सारा, all of you understood this?
Yes,
आलिया,
sir.
ठीक है। अच्छा, अब अब्दुल हमीद रीड कीजिए और बताइए। इंग्लिश है ना, केमिस्ट्री तो है ही नहीं अब, है ना? आपको कंपेयर करना है कि आपको, मतलब आपको पैसा दिया जा रहा है, पैसा लिया जा रहा है, ये चीज तो है अब्दुल हमीद, सही है? ठीक है, थोड़ा सोच के बताइए। पहले एक चीज देखते हैं, सबसे पहले सिस्टम एब्जॉर्ब्स 428 जूल ऑफ हीट। सो क्या हो रहा है, सिस्टम को दी जा रही है कुछ या सिस्टम से ले लिया जा रहा है कुछ?
दिया जा रहा है।
दिया जा रहा है, तो पॉजिटिव या नेगेटिव?
पॉजिटिव।
तो 428 विल बी इन पॉजिटिव, ठीक है ना? अब इधर आते हैं प्लस। एंड डज वर्क इक्विवेलेंट टू, तो अब बताइए ये कौन कर रहा है काम? आप इसको हटा दीजिए।
सिस्टम वर्क करना।
कौन कर रहा है? सिस्टम कर रहा है ना। तो सिस्टम
हाँ
से हमने क्या किया, वर्क लिया। सिस्टम से हमने काम लिया, काम लिया तो क्या पॉजिटिव या नेगेटिव? आप
या तो
आंसर
नेगेटिव।
बताएं। लिया तो नेगेटिव, बस खत्म बात। क्या हो जाएगा, माइनस 286।
286।
हाँ तो ये क्या हो जाएगा, 428 माइनस 286 जूल। दिस विल बी इक्वल टू हाउ मच, 142 जूल्स।
ओके सर समझ आएगा।
समझ आ गया? ठीक है ना? तो खुद से थोड़ा
यस सर।
ट्राई करें समझने की। चलिए, अच्छा इसके बाद एक बहुत छोटा सा हम टॉपिक करा रहे हैं आप लोग को, उसके बाद इस क्लास को एंड करते हैं। देखिए ध्यान से, we have all learnt about the work which is known as force into displacement. We have learnt about this work. सही है guys? इसको please tell me. In our
Yes, sir.
9th standard, force into displacement, and if you studied this in your 11th standard, it will be FD cos theta. इस तरह से कुछ होता है ना, FD cos theta पढ़ा है आप लोगों ने अभी,
Yes, sir.
है ना? FD cos theta,
Yes,
ये सारी
sir.
चीजें पढ़ी है। But hopefully you will know that ऐसा खींचातानी तो केमिस्ट्री में होती नहीं है कि हम किसी चीज को यहाँ से वहां लेके जा रहे हैं, है ना? एक मंकी दूसरे मंकी के ऊपर लटका हुआ है, पुली उली, ये सब तो चीज होती नहीं है केमिस्ट्री में, राइट? जैसे नो, करेक्ट? अरे बोलो भाई,
Yes, sir.
Yes, sir.
है ना? So obviously there will be no display, force will be obviously there, but there will be no displacement or something, right? अच्छा, so what is there in chemistry? It is pressure and volume. It is pressure and volume. So we have a work in chemistry which we call pressure volume work. So we are going to understand this part. Pressure volume work. Basically, it is the same thing only. It is the same thing only. When we were lifting this piston up, when we were lifting this piston up, we were obviously doing some kind of work. And the consequence of that work was we were applying, there was some kind of pressure change here, or you can say there was some kind of pressure change in the upward position, and volume was increasing or decreasing. If I am pushing the piston down, then I am exerting some kind of pressure. The volume is what? The volume is decreasing. So this type of work is known as, or other we can say, the calculation of work using pressure and volume. The calculation of work using pressure and volume is what? Pressure volume work. It is what? Pressure volume work. अब ध्यान से जरा इसको हम लोग समझते हैं, ठीक है? अच्छा, let me bring my piston and all, है ना? ये पिस्टन वाली चीजें बहुत इंपॉर्टेंट है. अरे हाँ जी, चलिए फिर से आप लोगों से बहुत गुजारिश है कि प्लीज डोंट राइट एनीथिंग, ट्राई टू लिसन एंड अंडरस्टैंड. देखिए और समझने की कोशिश कीजिए, ठीक है? ध्यान से बिल्कुल. प्लीज आप लोगों ने बोला पेन वेन ना छोड़ ही दीजिए बिल्कुल, है ना? हम तो ये कहेंगे पेन क्या कीजिए, पेन छोड़ दीजिए बिल्कुल. अच्छा, when nothing is happening in the piston, then we can say that the P external, whatever external pressure we are adding, it is equal to P internal. It is equal to P internal. बात सही है हाँ या ना? तभी तो बैलेंस है, इक्विलिब्रियम में तभी होगा. When we are not having any difference in the, when we are not having any difference in what? Any difference in the pressures, external and internally, we are not having any difference in the pressure, है ना? That is why piston is neither moving up. अगर मान लीजिए if the P internal was greater, अंदर से प्रेशर ज्यादा होता तो पिस्टन क्या होता? ऊपर भाग रहा होता. अगर बाहर से ज्यादा होता, if we were giving more pressure on the piston, then the piston would be moving down. The piston would be moving down. Let us suppose we have a case in which P external is greater than P internal. So P external is greater than P internal. Then what is going to happen? Piston will move down. Piston moves down. Piston move down. Next point we can write, as the piston moves down, as the piston moves down, volume changes. बात सही है हाँ या ना? समझिए जरा बात को आप. All of you please try to understand this. Let us suppose if the piston is moving down and we brought the piston to this particular level, and I'm writing it this in red. We have brought the piston to this level. Okay, so initial volume was this much, current volume is this much, so obviously volume has changed. Correct guys? Yes or no? Please tell me. अरे इतनी बात समझ में आए तो बताइए. Please लिखने की जरूरत नहीं है कुछ भी, है ना? हम लिख रहे हैं. Please don't write. Leave your pen aside, है ना? Please listen. I can say this is the volume changed. हाँ या ना? This is the volume change. Correct, guys?
Yes, sir.
है ना? Now please see the piston. Obviously, all these things will be either, in a cubical shape, or we can have a cylindrical type of shape, right? We can have cylindrical type of shape. What is the area? Now, whatever volume we have decreased, we can represent it by a cylinder. सही है हाँ या ना? Correct है guys? अरे बोलो.
Yes.
Container भी है तो cylinder है ना? अच्छा. We can say that this is the area of piston. इतना ही area होगा ना piston का, तो ऊपर वाला भाग. सही है? This is the area of piston. And this is the length, है ना? जहाँ पे piston move किया. This is the length in which piston has moved. अरे बोलो यार, बात समझ में आ रही नहीं आ रही है यहाँ तक बताइए.
Yes, sir.
Is it clear?
Yes, sir.
This is the area, है ना? This is the length, and area into length will be equal to the volume. So if I talk about the change in volume, so this much change in volume is present, and it will be equal to what? The area of the piston multiplied by the length. Is this clear till here? Yes or no? Please tell me.
Yes, sir.
ठीक है. अब दूसरी चीज सुनिए. Now what is? See, we know that what is pressure? Pressure, it is equal to force upon बोले भाई, force upon
Area.
एरिया। अच्छा, तो फिर ये बताइए आप लोग, फोर्स कैन बी रिटन एज प्रेशर इनटू एरिया, सही है हाँ या ना? बोलो भाई
Yes,
लोग।
sir.
Yes, sir.
Yes.
ठीक है। व्हाट इज वर्क? वर्क इट इज इक्वल टू force into the displacement, and as you can see the theta यहाँ पे मैटर नहीं करेगा because the direction of the movement is same as the direction of the force, there is no change in the angle, ठीक है ना? तो cos आपके पास रहेगा cos 0 which is equal to 1, so theta does not matter। थोड़ी सी फिजिक्स हम तो आती है, I know some physics basically। तो फोर्स क्या लिख सकते हैं इसको? प्रेशर इनटू एरिया एंड द डिस्टेंस इट हैज मूव्ड, इट इज नथिंग बट इट इज इक्वल टू एल। अरे बोलो भाई, बात सुना रही नहीं आ रही है? इनटू एल।
Yes.
अब सुनिए ध्यान से। सो आई कैन राइट दिस एज इक्वल टू प्रेशर ए इनटू एल इज नथिंग बट डेल्टा वी। बात समझ में आई सबको? है ना? लिखना नहीं है अभी,
Yes, sir.
लिखना नहीं है बिल्कुल, ठीक है। सो वर्क इज इक्वल टू प्रेशर इनटू चेंज इन वॉल्यूम, प्रेशर इनटू चेंज इन वॉल्यूम। अब ध्यान से थोड़ा सुनेंगे लोग, बातों को ध्यान से बिल्कुल सुनिएगा, कुछ लिखने की यहाँ पे बिल्कुल जरूरत नहीं है, ठीक है ना? कुछ लिखने। नाउ if I talk about the volume change, if I talk about the volume change, give me a second। if I talk about the volume change, तो दो चीज हो सकती है यहाँ पे, राइट? दो चीज हो सकती है, क्या हो सकता है? Please see, what I can say in this case is delta V is equal to negative। negative का मतलब piston moves down, सही आया ना? Is that right? Yes or no? Please tell me। अरे बोलो भाई।
Yes, sir.
ठीक है, डेल्टा वी कैन बी व्हाट? नेगेटिव। अगर पिस्टन नीचे जा रहा है तो डेल्टा वी क्या होगा? नेगेटिव हो जाएगा। दैट मींस व्हाट इज हैपनिंग? द वॉल्यूम इज डिक्रीजिंग। वॉल्यूम इज डिक्रीजिंग, तब क्या हो रहा है? वॉल्यूम डिक्रीज होने से ही तो फाइनल माइनस फाइनल कम होगा, इनिशियल ज्यादा होगा। तो पिस्टन जब मूव करेगा तो फाइनल वॉल्यूम विल बी लेसर and the initial volume will be larger, that is why final minus initial will be negative। so delta v is equal to what? It is negative, piston moves down। if piston is moving down, तब आप ये बताइए work is done। पिस्टन अगर नीचे जा रहा है तो कोई बाहर से प्रेशर लगा रहा होगा ना, तो वर्क इज डन ऑन द सिस्टम। अरे बोलो भाई, आया ना?
Yes, sir. Yes, sir.
Yes, sir.
करेक्ट गाइस, वर्क इज डन ऑन द सिस्टम। सिमिलरली if we have rotate horizontally, see another thing is when delta v it is equal to positive, so piston volume is increasing, तो piston ऊपर जा रहा होगा, piston moves up। in this case work is done by the system। आया ना? सही है। अच्छा, इस केस में
Yes,
वर्क
sir.
इज डन ऑन द सिस्टम, तो वर्क को क्या आना चाहिए था? वर्क इज डन ऑन द सिस्टम, तो वर्क को आना चाहिए था पॉजिटिव, और यहाँ पे वर्क को क्या आना चाहिए था? नेगेटिव। सही है? अरे बोलो भाई,
Yes, sir.
आया ना?
Yes, sir.
लेकिन इफ आई प्लग इन, सी प्रेशर कैन नॉट बी पॉजिटिव और नेगेटिव ना, प्रेशर तो पॉजिटिव नेगेटिव नहीं होगा। लेकिन इस केस में अगर आप देखिए वर्क क्या आएगा? वर्क इज इक्वल टू पॉजिटिव डेल्टा वी। पॉजिटिव मतलब प्रेशर को हमने पॉजिटिव लिया है, इनटू डेल्टा वी क्या है? डेल्टा वी इज नेगेटिव, तो वर्क इस केस में क्या आ जा रहा है? नेगेटिव आ जा रहा है। वर्क इज कमिंग आउट टू बी नेगेटिव इन दिस केस, बट आई टेक, इफ आई टेक दिस केस हियर where W it is equal to P delta V, and W it is equal to pressure is always positive and delta V is also positive. So work will be coming out to be what? Work will be coming out to be positive. So when it should be coming positive, it is coming negative. When it should be coming negative, it is coming positive. So the best option is to add a minus sign here. Tell me guys, yes or no, please tell me. All of you understood this?
Yes, sir.
Okay. So we do a bit of change in the what? In the formula of work to get the work as positive or negative. Just remember one more thing. This P we have initially stated it is what? It is P external. It is external pressure. Okay, so we'll add one more part here. This is what? This is P external. Okay, now you can please write this part, pressure volume work. Let me know if you are done writing. Okay, you just need to write till here. Okay, you don't need to see the cases here, which you have written delta V is positive or negative. You just need to write till here. Minus P external into delta V, it is equal to the work. This is the pressure volume work. That means we calculate the work using pressure and volume changes. The definition of work is still F into D, but we use pressure and volume to determine the amount of work that is done. Abdul Hamid, you understood these parts? Yes or no, please tell me.
Yes, sir.
If all of you are done, please go to the Learnivio app. You will see an assessment. So yesterday, did you guys have any assessment? There was some technical glitch in the app, I guess.
No, sir.
No, there was no test yesterday, no. So you'll have the same test and basic terminologies and everything. So please give that test. Okay, and then in the next class, we will be dealing with some more numericals. Okay, so this class, I mean, thermodynamics, not much class are left. Okay, please understand this. This is your second class. I think in what I can say, second class now. We are done till pressure volume work. So maybe we will be needing 4 more classes, maybe 4 more classes. Okay, so in 6 classes, inshallah, this will be done. Can you guys see the
Sir, I
test?
have a doubt in the assignment.
Can you tell me?
So in chemical bonding,
In what?
chemical bonding assignment.
Yeah, chemical bonding. What doubt? Tell me.
Although geometries of NH3 and H2O molecules are distorted, tetrahedral bond angle in water is less than that of ammonia.
I think you have said 2 different questions, right?
Sir?
You said 2 different questions. Can you send me the question?
Okay.
I heard NH3, NH2, only that much. Why is the, you sent somewhere?
Yes, sir.
Although geometries of NH3 and H2O molecules are distorted, tetrahedral bond angle in water is less than that of ammonia resource because of the 2 lone pairs in water molecule and 1 lone pair in NH3, right? One thing, if you remember, lone pair repulsion is greatest, followed by lone pair bond pair, and then followed by bond pair, right?
Yes.
Okay. So if I draw the H2O molecule, it will be H, oxygen, and H, and it will be having 2 lone pairs, right?
Yes, sir.
And what about ammonia? Nitrogen will have one lone pair and 3 hydrogens. Correct. Now please
Yes.
see that this lone pair will be repelling this lone pair. Sorry, this lone pair will be repelling this bond pair. This lone pair will be also repelling this bond pair. And there will be repulsion, a large repulsion between these two lone pairs also. So that is why intently what is going to be happening, that this HOH bond angle, it is going to decrease because it is getting repelled. So obviously what is going to happen? The hydrogens are coming closer together like this, no? So what will happen to the bond angle? The bond angle will decrease, but it is not going to decrease the same manner in the ammonia, because here the repulsion is only by one lone pair. Here we have one lone pair, and here we have two lone pairs. That is the main reason. So if you want the answer would be something like due to the presence of. You understood the concept, yes or no, Harsha?
Yes, sir. Yes.
Okay, due to the presence of two lone pairs, bond angle of H2O is smaller.